You're standing in your kitchen, it's pouring rain outside, and you hear it. That faint, persistent humming coming from down in the basement. Welcome to this explainer on diagnosing a constantly running sump pump. Today, we're taking expert advice straight from Dr. Drain and turning it into actionable steps. We are going to decode exactly what that noise is trying to tell you about your property and how ignoring it could eventually lead to thousands of dollars in totally avoidable water damage. Let's get into it.
When you hear that relentless humming, honestly, it's human nature to just assume that as long as the machine is running, it's doing its job. You might even feel a sense of relief, right? Like, great, the water is being kept at bay. But is that continuous noise actually a massive red flag? Well, it is incredibly easy to mistake a struggling, completely overwhelmed system for a hard-working one. We need to uncover why that assumption could cost you dearly the next time the weather turns ugly.
So let's establish a quick baseline of how things are actually supposed to work down there. Think of your sump pump as a sprinter. It is specifically designed for short, quick bursts of work when the water levels inevitably rise, clearing the pit in these highly efficient cycles. It is absolutely not a continuous marathon runner. Understanding this design principle is the key to recognizing when your system is in distress. When it starts running like a marathoner, something in the equation has gone terribly wrong. Here is our quick roadmap for today. We'll cover the warning sign, why your pump is running constantly, the hidden dangers of ignoring it, a handy DIY checklist, and finally, when you need to call in the professionals.
Okay, diving straight into part 1, the warning sign, and what it means when that humming just won't stop.
Look, even if your basement is bone dry right now, which is obviously the goal, a pump that never shuts off is screaming for help. It's a massive indicator that your system is basically failing to handle the groundwater. It's taking in water way faster than it can comfortably push it out. Sure, day after day it might successfully prevent a flood, but it is operating right at the absolute limit of its capabilities. It's teetering on the brink, and literally one extra inch of rain could push the whole thing over the edge.
Let's move on to Section 2, identifying the exact culprits making your system run non-stop.
There is a surprisingly wide lineup of usual suspects here that can cause this one symptom. You've got environmental factors, like just too much water entering the pit. You've got mechanical failures, like a jammed switch or a float that's gotten stuck. Sometimes it's a frustrating obstruction, maybe poor pit drainage or a discharge line that's frozen completely solid outside. But a really common, super sneaky culprit? A bad check valve. This is the valve that stops gravity from pulling water back down the pipe. When it fails, all that water your pump just worked incredibly hard to push up and out just lazily flows right back into the pit. It traps your pump in this exhausting, endless loop of clearing the exact same water over and over again. Another major cause just comes down to the actual size of the pump. A smaller pump installed to handle your average water loads will handle typical weather beautifully. But during a prolonged, heavy storm season, that exact same pump gets crushed. It struggles against the sheer volume of water, causing near continuous cycling. The pump isn't necessarily broken, mind you. It simply wasn't sized for extreme conditions, and it's desperately trying to keep up with a demand it was never built for. So, what is the actual cost of just ignoring that noise? That brings us to Section 3, the hidden dangers. By forcing your system to run this unending marathon, you are rapidly degrading vital pieces of equipment hidden right inside the unit. The motor is running non-stop, generating excessive heat, which puts it at extremely high risk for internal burnout. Meanwhile, the impeller faces much faster physical degradation from the non-stop friction of moving all that water. And the float assembly gets subjected to drastically increased wear and tear. You are actively shortening the pump's lifespan, virtually guaranteeing a catastrophic mechanical failure exactly when you need the system the most. And here is the scariest part. The safety buffer you are left with in this scenario is exactly 0. A maxed-out pump means that if a heavier rain suddenly hits or a spring thaw accelerates, the incoming water will back up before your pump has any chance to clear it. It has absolutely no extra gear to shift into when things inevitably get worse. And it's not just about your soaring utility bills, though that definitely adds a noticeable expense during a wet month. Persistent running is often a symptom of a much larger disease for your property. It usually means water intrusion isn't just isolated to the sump pit itself. Moisture could be actively seeping into your basement through microscopic cracks in the foundation walls, or maybe poor grading outside is funneling water right against the house. The pump is basically fighting a battle it wasn't designed to win alone. All right, let's get actionable. Section 4, your DIY checklist to triage this problem before the next storm hits.
You want to start with these 5 simplest checks today. Number 1, just confirm that the float moves freely and isn't physically snagged against the side of the pit. 2, inspect your discharge line for any obvious blockages, like leaves or ice. 3, ensure that the line is pitched correctly so it directs water completely away from your home using gravity. 4, verify that the check valve is actually stopping water from returning to the pit, like we talked about earlier. And finally, go outside and check where that exterior outlet is actually dumping the water. If it's emptying into a spot that flows right back toward your foundation, you're just recycling water. Honestly, running through these 5 simple steps can solve the vast majority of humming issues without you having to spend a single dime.
But what if you've done all that and it's still humming? That's Section 5, elevating the diagnosis and knowing when to call the professionals. It is incredibly important to know your DIY limits here. You can totally handle clearing an icy pipe or unsticking a float, but a qualified professional takes it to the next level. They have the specialized tools to safely test intricate electrical components. They can do the math to accurately evaluate if your pump is just totally undersized for your specific property, and they can figure out if you need major exterior upgrades to fix the root cause. A pro can bring in the heavy artillery for true long-term peace of mind. They can install a higher capacity pump if yours is outmatched. They can set you up with battery backup systems, which, by the way, are absolute lifesavers when severe storms knock out your power. They can implement smart monitoring alerts so you get a ping on your phone about a rising water problem while you're at work, long before it becomes a disaster. And, if needed, they can tackle the outside of your home by adding French drains or comprehensive foundation waterproofing to stop the water from ever reaching the pit in the first place. Bringing this all together, Dr. Drain hit the nail right on the head with this quote. In short, when a sump pump runs constantly, treat it as a warning, not just normal heavy-duty use. That nonstop humming is an urgent emergency warning sign you absolutely cannot ignore because the financial and structural consequences of doing so are just way too high. Addressing the root cause early is the only real way to extend your pump's life, avoid a midnight emergency, and protect the foundation of your home. So, as we wrap up this explainer, I want you to ask yourself, is your system genuinely ready to survive the next big rainfall? Or are you just running on borrowed time?